This is Algebra 2B, Statistics Lesson 3, Measures of Spread. So first of all, we're going to start with standard deviation. Standard deviation measures the average distance from the mean. And it's kind of a complicated formula. What you need is the mean, and then you would need each data point's distance from the mean. Then you would need to square all those values, add them all up, divide by 1 less than the number of numbers, and finally root all that. Now that's complicated. I do have a table that's going to do each of those steps for us when we get down there. But the whole point of standard deviation is if you have a high standard deviation, that means your data value is very spread out. And if you have a lower standard deviation, that would indicate that you have your data much more clustered around the mean. And that's useful when we're comparing two data sets so we can see if people were much more consistent or had a lot more variability. Outliers are when you have a data point that is significantly different from the mean or from the rest of the data. We'll say very far away. And that is very loose, okay? I want to have a much more mathematical definition so I can determine if something is very far away or just kind of far away. And we're going to say greater than 1.5 interquartile ranges from the interquartile range. And we're going to use what we call fences to help us determine if something is an outlier. So if a data point is less than 1.5 interquartile ranges from the interquartile range, it becomes an outlier. Or if a data point is greater than, and these look pretty similar, it's just upper quartile plus or lower quartile minus, okay? Skewed left, if your data has an outlier, it would become skewed. If it has a lower outlier, skewed left in a, what should we do, box plot? In a box plot would mean that you have a lower outlier, and then the bulk of your data is really up here. The tail is on the left. If we were talking about a histogram, you might have a low bar, and then maybe a gap, maybe another bar, but most of your bars are going to be out here. So I'm trying to draw a graph where you'd have a lot of low data, but then a lot of high data. Let's make him look more like a histogram, right? So low, high, that's skewed left. Skewed right would be the opposite. So on a box plot, we're going to have some low data, and then skewed to the right, we see a long tail with possibly an upper outlier, okay? And then in a histogram, again, we have a bunch of tall bars on this end of the graph, and then it kind of levels off. Maybe we have a gap, maybe we don't, but then there's going to be one short bar over there. I guess in between you'd see symmetric. I don't have that on here, but I'm going to draw a symmetric one where there's a kind of low, and then high, and then high, and then back low again. Don't really have any outliers, right? That's symmetric. Okay, let's try some of these definitions and formulas. Example A, the table at right gives the points scored by the Chicago Bulls players who played over 90 games during the 97-98 season. Find the 5-number summary. So we have Michael Jordan up here with 2,357 points being our maximum. And we have Bill Wennington scoring 167 points as our minimum. To find the median, right, we need to match up low to high and find the middle. These are ordered for me, so that makes it easy. My median would be right here at 416. And to find our quartiles, again, we're using the exclusive method, which means 2357 matches up with 663. We do not include the median in our quartile calculations. So one more low to high shows me that my upper quartile is at 843. And again, 376 matching up with 167. And matching up right here, we have our lower quartile. So I'm going to write these out. We have 167 as the minimum, 288 as the first quartile, 416 as the median, 841 as the upper quartile, and 2,357 as the maximum. Example B says calculate the outlier fences. I'm going to label my lower and my upper quartiles because those are the two numbers that we're going to need to go into our fence formulas right here. Okay? So scroll up. I guess you got a piece of paper. You don't have to scroll. I got them in my brain though, so I'm going to put them off the screen. The lower fence would be our lower quartile minus 1.5 times the inner quartile range. And our upper fence would be our upper quartile plus 1.5 inner quartile ranges. So I'm going to go to my handy dandy and we will type 288 minus 1.5. Sorry, I think tapping that email notification messed me up. Okay. Minus 1.5, 841 minus 288. Bam, bam, bam. That looks good. My lower fence is negative 541.5. And back to the handy dandy, I will hit replay and just change my first 4 characters. And I'm going to keep everything else the same. 841 plus gives me an upper fence of 1,670.5. So, I think, just looking at the data, Michael Jordan looks like an outlier, right? He's in the 2000s. Nobody else even broke 1,000, right? But then how far away do you need to be an outlier, right? If he had 1,200, right? He's in the thousands, but he's only a couple hundred off of the second place player. Do you need to be at 1,500, 1,600, 2,000, right? What makes you an outlier? And that's what the fences do. They give us a definitive spot what makes something an outlier. So if he had only scored 1,670, he would not have been an outlier, right? It still seems crazy far from 984, but you need to breach that 1,670 point to become an actual definitive outlier. So we do have an upper outlier. Michael Jordan at 2,357 points is greater than our upper fence. Okay. And now we're going to make a modified box plot. Modified box plot looks a lot like a regular box plot. We need a number line first. And I'm going to go 0, 1, 2, 3,000. The difference being, if a data point is an outlier, you no longer extend your whisker to that point, okay? So this is 1,000 here, which means this is 500 here, and most of my graph is going to be way down here. So I have my minimum at 167, my first quartile at 288, my median at 400. I know that this is 500, right? 841 is going to be a little higher than halfway up there. And I do have Michael Jordan up here. This would be about 2,500, way up there. So when I use my middle 3 to draw my box, I'm going to extend my whisker down to my minimum. I am not going to extend my whisker up to my maximum. For a modified box plot, I'm going to go to the highest data value that is not an outlier. And in this case, that is 984. So I'm going to extend my whisker to 984. So that's not even 100,000. That's right there. But then we still do have this point up here to show that there's an outlier. If we had multiple outliers, we might have multiple points, right? But just with Michael Jordan, we have our 1 dot way up top showing that he's an outlier. And our whisker, like I said, extends to the highest data point that is not an outlier. Okay, letter B, the table at right gives the distance traveled in feet by 8 rubber band launches. Complete the table to calculate the standard deviation. So I wrote this crazy formula at the top. Sigma bar x minus xi squared over n minus 1. It's crazy, but this formula this table is going to do all that work for us. So the first thing we need to do is calculate a mean. That's what this symbol here means, mean. So we're going to add our 8 values and then divide by 8. So that is 12, 14, 11, 11, 18, 7, 9, 14. Get the sum and then divide by 8. Our mean is 12. Step 2, we are going to subtract. Okay, this header up here tells us what to do. We're taking each data value and we are subtracting the mean. So how far is 12 from 12? It's 0 away. How far is 12 from 14? Now technically that's 2, right? 14. 14 minus 12 is 2. Next one is how far is 11 from 12? So this is the one where technically we're doing 11 minus 12, so it is a negative 1 because 11 is 1 from 12, but it's lower. Okay, and then again, how far are we from 12? How far are we from 12? Bam. Each data point, subtract the mean. Now we're going to square each of those values. So 0 times 0, still 0. 2 times 2, 1 times 1. Remember, negative times a negative is a positive. So you should notice that every single one of the values in this column, even if we had a negative here, it's a positive here. Okay? So I'm going to keep on squaring down the row. Everything times itself. Step 4, we're going to do the sum again. So we're going to add up everything in that last column. So that is 4 plus 1 plus 1 plus 36 plus 25 plus 9 plus 4. Our sum of these 8 values is 80. Step 5, this is called variance. We're going to divide by 1 less than the number of numbers. Normally for mean, we add up and divide by how many? But we're going to divide by 1 less. So in this specific example, we are dividing by 7 because we have 7 data points. Okay? 80 over 7 looks like 11.4. And the final step in calculating the standard deviation is to root that value. And our standard deviation is 3.4 if we round that. So on average, our data points are 3.4 feet from the mean. Okay? That is it for our notes. Good luck on the exercises, and please let me know if you have questions.